Now, I will talk about weld defects in submerged arc welding, so processes. And we are going to use data from this kind of process. That's why I'm introducing it here. I will not go into details, but I will just give you some general idea of how it works and to show you the data we have to work with for the demonstration. Okay? So what you see here in this image, you see here, this is called a flux. It's like a granular powder, okay, that comes out from this a device. And here, under this flux, the welding process is happening. This is one of the processes that are being studied and developed in the PeneloPe project. So this here is moving to the right direction, okay? And while it is moving, it is soldering these metallic parts, okay? And then you have here left behind this flux. Normally you have a vacuum system to remove the excess and reuse this flux, okay? So here a bit more in details. We have here this sketch. So this is the workpiece. What you can see here are two blocks of metal, okay? And here is the welding system to joint these two metal parts. So what happens? You have this device that starts here and moves in this direction. And while it's moving, it's soldering and lefting behind this flux that we saw in the previous image. Here we have the feed wire, which comes here inside. And here it forms one arc, and it has a high temperature that melts this wire, which is a metal. And it make the welding and join these two parts, okay? And here is flux hop is like deposit of flux, this granular powder. And with the time, this is moving, and this is injecting this flux here. So this flux protects also our eyes. We cannot see this very intensive process that has is very bright. Is really a soldering emissions of light that comes from it, and you should have special glasses to see, but because of the flux you don't need. And you have the control system to operate all this device, okay, and to make this welding. Here below you can see an image of the system we have at IMEN. In this case, we have two torches. Here we can see that it's just one, but here we have two. And here is the vacuum system cleaner to remove the excess of flux and then reuse it. And also, because this is in lab scale, we have some sensors here to detect signals, like this pyrometer to detect temperature profiles. This is infrared thermometer. Then we have here a camera to make videos of the process. Here we have a profilometer to see the surface of the weld. Okay, so we are acquiring data while we are doing the weld. And also we have access to the process data, like the current, that the electrical current that is used, the voltage, okay, in a time series signal. No? And here on the right, you can see an image of this piece that we call coupon that was done using this, the weld was done using this method, Like you can see, we have like some extensions at the beginning, at the end, to start a bit before and finish a bit later, to have more homogeneous weld passes here. And this metallic parts has, for example, here from height 50 millimeters, and from length 600 millimeters, and here width together is around 30 millimeters. So this is really heavy, and you cannot take this by hand easily, not at all. So you need help from a crane to put it here, to remove. These are really heavy parts, okay? And here in the middle, you can see the weld. So here, when you are doing this process, you repeat it many times until you reach the top here. This has a shape of a V, okay? When you put it together, these metals are a V, and then you fill this part here with the weld. And what you see here in this part, this solid part here, are some crust or some, let's say, solid part that were over the weld from the flux, because you can, when you pass here, the flux that is in touch with the weld, it become hard and makes this kind of pieces here. And the excess of flux you can recover with the vacuum system. Okay, this is the general overview of this process, so you can understand. And what is important is to know the kind of defects that can appear in this process. For example, as I told you, we have a V shape here, a bevel, and you fill it with the weld. And we have here a kind of defect called underfilled, because it did not reach the top part. Then we have here undercut, which have these drops here on the sides. The pore penetration, when here you could not reach the bottom part of the piece. Then lack of fusion. Then you have parts that are not joined. The welding didn't work so fine. Then a sputter. This is when you perform the weld, like moving this direction welding, and then you have residuals or rests of the weld that were sparkling and jumping. They got around doing this kind of thing. So a lot of small drops here, okay, that you cannot easily remove. And porosity, okay, this happens very often, especially when the flux has high humidity, because when you heat, what happens to the humidity? It turns into gas, and this gas bubbles get trapped inside the weld, so you have a weld looking like a cheese. And overlap, when you put more than what is expected. And inclusions, like for example, if you remember that solid parts that I showed you that remained from the flux, if you cannot remove it from the top of the weld, then when you pass the second layer of weld, it will have this flux trapped there, and then this is called slag inclusions. And excess of reinforcement, when we have this kind of shape. Also cracks, this may happen, that you don't have a solid homogeneous weld and you get cracks inside the weld. Or if you burn it through, then you have no weld here. Okay, so these are the kind of defects that may happen. And here you can see an image of a coupon that at Amen. Okay, and in this coupon or the sample, we have identified two different kinds of defects, and they are namely cracks and one pore. Let's increase the image. So let's have a look in the cracks. So you can really see here the crack formations on the weld. So this is one of the kind of defects I just showed you. And also the pore. You can see here a hole. So it's a pore that was formed during the process. Okay. So then we can have also some other kind of defect, which is incomplete fusion. As you can see here in this image, now you have the two pieces of metal and in the middle the weld. And here you can see that we didn't have a very nice weld in this part. So we have here incomplete fusion. So many different kind of defects may happen and during the process. And I'm showing you here some of them. Okay.